Hey, this is lesson 2. It's going to feel oddly similar to lesson 1. We're still doing triangles, special right triangles. They're not that special. I don't know why we keep calling them that. But guys, today we're doing 30, 60, 90 degrees special right triangles. So let's start the same and do Pythagorean theorem on these two triangles up top. That's going to help us discover the pattern going on between the sides in 30, 60, 90 triangles. So here we go. Remember that in Pythagorean theorem, the hypotenuse has to go by itself. These guys are the legs. So I'm just going to go x squared plus 6 squared equals 12 squared. Do your exponents first, order of operations. So 36, 144. Then subtract the 36 over. So 108. And notice that it does say again, which it probably will on both of these lessons here, it's going to say simplest radical form. So when I go to square root this, I need to do a factor tree on 108, which I'm definitely going to run out of room. So let's do it up here. If you're not sure what goes into 108, it's even, so you could just divide it by 2. Some of you just like live in the 2 zone on these, which is totally cool. So like 2 and 27. I could do 3 and 9, and then 3 and 3. All right, so here's how I'm going to rewrite this. For every pair, remember, you bring one of those numbers out front. So I see a pair of 2s. I like to cross them off as I use them. Pair of 2s, so 1, 2 comes out front. Pair of 3s, 1, 3 comes out front. Those get multiplied. That 3 doesn't have a pair, so it stays underneath. So the best answer here would be 6 radical 3. That's my x value. We'll fill that in on the triangle. All right, let's do one more. Always helps to have like more than one example to notice a pattern. So here 10 is the hypotenuse, so I'm going to do x squared plus 5 radical 3, and I'm going to put that in parentheses, equals 10 squared. Be careful when you square this. You can always write it twice. I showed you that yesterday in an example. I'm going to be lazy, or maybe be smart, I don't know. I'm going to use my calculator. Look, you can just close the parentheses after the ones that got opened with the radical, then close the bigger set. If you type it in like that, it's going to spit it out to you. You could write it out longhand if you feel like you can't figure that out. But that would be x squared plus 75 equals 100. Subtract your 75 over. Oh, this is nice. Yay, no factor tree. And then when you square root that guy, perfect square, square root of 25 is just 5. So we'll fill that in on my picture. All right, I'm going to go ahead and highlight the side lengths so we can notice the pattern just like we did last time. So 6 radical 3, 6, and 12. 5 radical 3, 5, and 10. All right, so check it out. Like I said, there's another pattern happening here, guys. That can be a lot of work, especially if you have to do like a big factor tree like that. That can be a lot of work to do Pythagorean theorem. So let's pick up a shortcut, make our lives easier. Now, with triangles that have 30, 60, 90, it's a different pattern than the ones with 45, 45, 90 degree angles. But know that it's always got to be 30, 60, 90 for this specific shortcut to work. If those aren't the angle measures, this does not apply. We can use this pattern, like I said, as a shortcut. Yay, we love shortcuts. All right, so here it is, and I'm going to generalize it. Again, this feels really similar to last lesson. I'm going to generalize it and then show you how to use it. You don't have to memorize all this. You just have to know how to apply it. So here's my triangle, 30, 60, 90. Now, we need to talk about the fact that the legs on this triangle are not the same. In a 45, 45, 90, they were the same. They're not the same here. One of the legs is shorter than the other one. The short leg, and I'm going to call it the short leg and the long leg, the short leg is across from the smaller angle. So across from your 30-degree angle, that side right there, that's the short leg. Okay, you'll see me talk about that a lot. I'm going to call that leg just X. That's the leg that we use to figure out all of the other pieces in the triangle. Okay, so these are the big ideas for today. If you take this short leg, and I don't know if you guys can like pick this out, but like in this triangle, across from the 30, that's the short leg. Over here, this would be 30, 60, 90. Across from the 30, that's the short leg. So short leg, long leg, hypotenuse. If you kind of look at the short leg and the long leg here, do you notice that the short leg and the long leg, if they just stick a radical 3 on whatever the short leg is, that's the long leg. So that's the first thing I want to write. If you do the short leg times radical 3, gross radical 3. Also, who discovered this? They need to get a life. But if you do the short leg times radical 3, that gives you the long leg. I wish it was prettier than that, but it's not. So on this one, if I call the short leg x, I'm going to call the long leg x radical 3. To go from the short leg to the hypotenuse, so it's like 6 to 12, 5 to 10. You just double the short leg. So the short leg times 2. That's going to give you the hypotenuse. Yay. Okay, these are the big things to know. Do the same thing you did last time, just 2 equations versus 1. So check it out. Let's practice finding the length of the leg. And this is all about the short leg. You've got to look for the short leg first. And I'm going to make a note of that. You've got to find the short leg first before you can find anything else. Okay, so keep that in mind. This is a 30, 60, 90. That's always going to be the case if there's a 90 and a 60. And that one's good too, so I know I can use these shortcuts. Now, the short leg, again, that's across from the 30. So right here, that's x. Now you've got to step back and say, well, what piece did they give me? They gave me this piece, which is 8, which is the hypotenuse. That's going to help you decide which one of these shortcut equations is going to help me. The one that uses the hypotenuse is going to help you. So I'm going to focus on this second little setup here. If I do the short leg, which in this case is x, and I multiply it by 2, that should equal whatever the hypotenuse is, which in this case is 8. Okay, so that's super easy to solve. Divide it by 2. And x is 4. The short leg is 4. Now that I have the short leg, I can find the long leg. And that's all they want me to do is like fill in the missing side lengths, find my variables. So long leg equation's right here. If I do the short leg and I times it by radical 3, the short leg's 4. That's going to give me the long leg, which is across from the 60. In this case, that's y. And that's solved. Y is by itself. Yay. So much quicker, though, than Pythagorean theorem. And I couldn't do Pythagorean theorem there. Directions should say simplest radical. You can't do SOHCAHTOA either, because that'll never give you a radical. So see if you guys can do number 2, find x, find y, get the short leg first. I'll ask you the answers. Definitely get your work on your notes here. It'll help you in the future. All right, on the back, we just have 2 examples. So hopefully this isn't too time consuming here. But here's where like some radical rules come in. But I'm still thinking, these are my 2 shortcuts from the front. So here they are, so I don't have to flip back and forth. I'm still using these guys. I still want to look for the short leg first. Make sure it's a 30, 60, 90 triangle. It is. Across from the 30, this is the short leg. Okay, so kind of keep that in mind as you start. I need to find the short leg first if I don't have it. So I've got to find the short leg. This time, though, instead of giving me the hypotenuse, they're giving me the long leg, 5. So I look for the shortcut that uses long leg, and that's this second one here. I'm going to plug the legs into this guy. So short leg times radical 3, y times radical 3 should equal the long leg, which is 5. Not too different so far, but now I need to solve for y by dividing by radical 3. And here's where I'll have to do what we were doing yesterday. I just have to rationalize the denominator. So I don't know, hopefully after yesterday's lesson, that doesn't weird you out too much. Whatever the denominator is, you just multiply by that exact thing on top and bottom. And that will cancel out the radical on bottom, which is super, super convenient. So that's going to be on top. You can't multiply those. You just stick them together because it's a plain number and a radical. On the bottom, square root 3 times square root 3 is square root of 9. And the square root of 9 is just 3. So really, like, I don't even write it. The square root just cancels out. And it's just 3. So that's my answer. Ooh, it's not pretty. But it's 5 square root 3 over 3. That's my y value. That's my short leg. Okay, so check it out. Now to find the hypotenuse, I have the short leg, so I'm okay to like set up this first equation right here. If I do the short leg, which is beautiful there, it is 5 radical 3 over 3. If I multiply that by 2, that'll give me the hypotenuse, which is x on this example. Now I just figure out how the heck do I multiply those two things? Here's where my mind would go. Make this a fraction over 1, multiply the numerators, multiply the denominators. The denominators are a little bit easier to look at. 3 times 1, that would just be over 3. On the top, when you multiply 5 radical 3 times 2, you can multiply the plain numbers there. You just kind of like leave the radical 3 out of it, or just stick it on at the end. So do 5 times 2, 10, stick the radical 3 back on. You can't simplify that any further. Don't divide those. That has a radical. This doesn't. Can't simplify that fraction out front. So that's your x value. Good stuff, people. All right, let's go ahead and do number 2 here, and then yay, we're done. 30, 60, 90 triangle. I know these shortcuts will apply, so let's go ahead and put them into play. This time they give me the short leg, so this is kind of nice. That's always the best case scenario when you have the short leg, because then you can find either one first. So maybe let's just do the hypotenuse. So short leg, which is radical 6. If I multiply that by 2, that gives me the hypotenuse, which is y in this example. Okay, so you just got to think, how do I make that look nicer? I cannot get 12. I can't multiply those. Radical number, plain number. So most of the time we'll just like swing the 2 to the front and we'll say y equals 2 radical 6. Okay, so that is the hypotenuse. Now I can get the long leg x by using the second shortcut. So the short leg, which is radical 6, times radical 3 should give me the long leg, which is x. I can multiply those numbers to say 18 because those are both sitting under a radical. Man, the radical rules really come back to get us in this unit. Yay. Okay, this is not the best answer though. You can make that radical nicer. This actually breaks down into a factor tree, and you'd always want to look for that if you can. The more simplified the answer, the better. So that breaks down. There's a pair there, so I can rewrite this. There's a pair of 3s, so I can bring 1 3 out front. That 2 doesn't have a pair, so it stays underneath. All right, that's lesson 2 for you.